morning, everybody, again. I think we should go ahead and get started. Um, Let me quickly see. Okay. Um, as you all know, my name is Nitya. I am one of the coordinators for Agora Engineering Circle program, and Karthik is unfortunately unable to make it for the class today due to some personal emergency. So it is me and Shagan who is gonna go over the class today, and it's a little bit gonna be different from what you were doing earlier, learning earlier with Karthik, because the goal for us, for you today, would be to kind of understand the concepts of artificial intelligence and know what is data science and high level kind of try to understand what is a machine learning algorithm and try to relate to the real world applications in terms of okay, this is where it is used and this is where it's kind of applied and all those things. So this is completely on a very lighter note, on a high level. It does not go into coding or programming concepts. um, and for the same reason, we wanted to keep it very interactive. So the chat will be disabled for today. Feel free to unmute yourself, or we would also try to pass at the end of every slide for you to kind of ask questions then and there. The goal is again like to keep it very interactive, very discussion oriented, and we will try our best to answer any kind of questions that you might have on this field. But this is, as you know, it's a vast field. So if there are anything that we are unable to answer today, we might take it back and come back to you offline. Um, does it sounds good? Any questions before we start for today?
No questions.
Perfect. Let's get started. I'm going to share my screen. Let me know when you're able to see my screen.
Yeah, we see it.
Okay. Give me 1 second. There are some technical issues here. Okay, there you go. So briefly, I mean, again, today will be a shorter class than your usual class timings. And it just depends on how long you want to go in terms of like discussions and Q&A and stuff. But overall, our agenda for today, we are breaking it into two classes, right? Like today, for the first 1 hour, maybe we'll be speaking more on artificial intelligence at a high level and try to go over the real world applications and see some of the AI in actions. And I also wanted to take this opportunity to a little bit keep you guys informed of some of the career options that you have, because I know you guys are like high school students trying to think about what you want to go do in future. So a little bit exposure into career options with respect to data science is what I wanted to take you through today, and kind of understand the difference between AI, machine learning, and deep learning. I know this is the buzzword for today. Everybody talks about machine learning, deep learning, AI, but do you really know what is the difference between these three? I'm like kind of able to clearly communicate to people when they ask you what is machine learning, what is data science, what is AI. Are you able to like communicate in a way that invokes clarity? So that's something we will be looking at today, and some of the amazing things that AI can do in real world applications. And AI in action, that's a cool video that I would be showing you. It's kind of interesting and exciting. And why AI now in terms of enablers, right? Like what's causing this AI to be becoming one of the booming buzzword in industry today? Why so much hype about AI today? And not, although this concept is not new, but it's like gaining a lot of momentum in this particular time frame. Why so? And branches of AI, and Shagan will also be taking us through his own practical experience here in terms of real-time use cases of AI. So this will go about for like an hour or so, approximately, and then we'll break for 10 minutes. And then our goal is for the second session is to go over a little bit deep dive into machine learning algorithms. Again, on a high level, what is a machine learning algorithm? What kind of algorithms you have? There are like plenty of tons and tons of algorithms, but to keep it on a high level for you guys to kind of digest the fact and try to again relate to how it is being used in real time use case. So this is pretty much the agenda for today. Again, any questions before we move on? Okay, so let's get started. Let's keep it, again, as I said, interactive, and feel free to stop us at any point. What comes to your mind when you think of AI today? Anybody?
Do we have to raise our hands or what? Do we just unmute?
Just unmute yourself and like go over.
Okay, so like when I think of AI, I usually just think of some kind of computer code that automates something for you.
Okay, automation is one that comes to your mind. Anybody else?
Whenever I play like video games, I can like play against the CPU. So that's what I think of when someone says AI.
Got it? Video games and your GPU graphics. Exactly. Next.
I think of like an algorithm where you can feed data and it'll like keep learning.
Good. Keep feeding data and keep learning. Okay. Anyone else?
When I think of AI, I think of Alexa and Siri.
Alexa and Siri. Excellent. Why not? Right.
When I think of AI, I think of like a robot that can perform its own functions and act like a human.
Absolutely.
When I think of AI, it's kind of like
What else?
it's kind of like a way. It's kind of like a language in which specific robots or just like machines use to operate on.
A language that machines used to operate on. Yes. Anybody else?
I just think of anything that's like made by humans that can do stuff, basically.
Made by humans, made for humans, right? That's definitely a way to put it. Any other?
When I think of AI, I think of like space, like recently the automated spaceships like from SpaceX.
Spaceships, absolutely. Think about other real world examples and think where you think can come from that angle. What do you think AI to be?
When I think of AI, I think of chatbots and how they're chat.
Absolutely.
When I think of AI, I think of bots on social media removing anything that shouldn't be there.
Can you elaborate that a little bit?
Like, for example, if you post something that you should not have, then you could install a bot and that bot would detect it and delete it.
Some kind of a arbitrator and some kind of a cleanser who kind of filters the unwanted data, right?
Yeah, like a filter.
Mm-hmm.
A chat filters.
Absolutely.
When I think of AI, I just think of something virtual that tries to act like a human and it accomplish a task that that humans do not have time to do.
That's a good one. So, anybody else before I kind of put in my thoughts? Okay, so pretty much whatever you guys said, everything is correct, right? Like somebody said automation, somebody said spaceship, somebody said chatbot, somebody said social media filter, somebody said help human. Every Alexa and Siri, for example, everything is correct. Artificial intelligence actually is so widespread, but if you go to Wikipedia and kind of search what is artificial intelligence, it puts you a very complicated jargon, right? But very simply put, artificial intelligence is something you define the intelligence in a way machine can mimic and execute human task. So whatever human is doing, it kind of learns from humans and mimics our task. It makes our job easy. It makes us to be more productive in terms of outsourcing all those mundane tasks to these automated machines. So basically it's kind of our assistants. At this point, it's kind of assistants, but in future, you never know. You could always like, the way the artificial intelligence is going, it could surpass humans, you never know. But at this point, if somebody is throwing a question of artificial intelligence, you say you would be just better off to say it's an intelligence, defining it in a way that mimics and executes human task. Simply. Does it make sense? And in our world, like in our generation, as you said, if you had asked us earlier, like 15, 20 years before, do you know what is like artificial intelligence? We would always say robots, and that's our like video games, as you said, right? That's the only application at that point we knew that machines were doing something similar to what humans were doing, right? But today, it's not just robots, it's not just video games, it's like completely widespread. Like anything and everything human is doing in a cognitive way, if you're able to mimic and replicate that task in machines, put those intelligence into the machines and make them replicate that task, that field is an artificial intelligence field. Starting from automation to Alexa to Siri to chatbot to everything. Sounds good? Okay. Let's move on to the career options that I was earlier discussing, right? So the Venn diagram that I put in there is like pretty much self-explanatory. On one bubble, you have your computer science IT, which means your programming, software, that kind of a field. And the other side, you have your math and statistics, which is more into the research and the academia of math, like statistics and all those research work. And then you also have your domain and business knowledge, which kind of like, which more leads to like product management or business analysis or like sales driven, etc., etc. So in between all these things, it's where your data science sits in. So if you're looking to grow your careers in future into data science, you have pretty much these wider options to choose from depending on your skill set and depending on where your interest is lying, right? So in case you want to be more like a programmer, you would be better off into the software development field where you learn the machine learning models. Anything and everything requires your primary fundamental understanding of your data science. But once you know that, what you want to become is something that's totally up to your interest and passion, right? So if I am one of the person who don't want to be a machine learning developer, I don't want to be a machine learning engineer, I don't want to develop a model, but I have like solid understanding of the machine learning model, but I would want to implement code and implement that becomes like a software developer field, right? Like it's completely on that end. And if you are more interested, like if you're like math oriented, statistics oriented, who knows, like you might even come back with like a different algorithm. You can develop an algorithm by yourself. You wanted to do more research into the math area, that's definitely a very, very prominent area as well. And then you have this domain and business knowledge, as you said, like if I know my machine learning models, but I want it to be intelligently and smartly use it in a way that delivers business value, that generates revenue, that decreases cost, that time the career option is more for you to be in a business world. And some of the career roles that if you want me to call out, in math and statistics, it's more of a researcher. In computer science, it's more of I can like software developer, programmer, and all those things. And core data science itself, you have your data analyst, your data architect, your machine learning engineer, data visualization architect, business intelligence developer. so many things. And when it comes to this domain business knowledge, you have roles such as product manager, business analyst, etc. um, I would let again let you to digest this concept. You don't have to think too deep into it, but this is just a very initial exposure for you to kind of throw out the options in front of you. If you look at my profile, I was a software programmer, organic software developer turned business person. So right now I am a product manager at Farmers Insurance, working on some data science projects. So mine is more on the pink bubble, where I'm more a business person now, trying to leverage on the data science and machine learning models to apply it in real world and real time use cases. But that's just me transitioning from computer science to domain. But again, it's completely up to you and your passion and where your skill set takes you. Any questions on this slide before I move on?
Can you explain the difference between a programmer, software developer, and a software engineer?
Software developer and software engineer doesn't have like a big difference, but if you're talking about a machine learning engineer and a software programmer, you have a difference. Is that what you wanted to know?
Yeah, kind of. Can you just tell me a little bit more like what a software developer does?
Sure. See, when you develop some models, right, you have different ways to implement those models. One of the examples that I would say is like if I am a like machine learning engineer developing some machine learning models, let's say I developed a model that classifies a particular email as like spam or non-spam, or I developed a model for Zillow that estimates the house price given your location, square foot, and all those things. Let's say I developed some kind of a model, right? A if I'm developing that, I'm more like a data scientist or a machine learning engineer, because I need to know how to train my model, how to bring in the data into the model, tune it for accuracy, and keep tweaking it until I get my desired accuracy and keep maintaining it. That's more of a machine learning engineer's job, a data scientist job, which is completely hardcore. It's you what you guys are learning, or what Karthik is feeding you, is like completely into the fundamentals of that thing, because it's the core, it's the crux. Without understanding the fundamentals, you can never even develop a machine learning algorithm by yourself, right? So from core, you're developing something. A computer programmer would be able to integrate, pick that model and apply it into the computer systems that are already available in the market. It's more like integration and develop or apply that ML in a programming world. Like I take my machine learning model and integrate into my, one example is like, I'm a Java programmer, but I wanted to implement a logistic regression model. How do I embed into my already existing system? How do I integrate? Or let's say the machine learning model itself is an API. It's like a programming, ready to be shipped kind of item, right? How do I take it and use it into my applications like retail online applications, e-commerce applications? How do I embed into my applications and use it for my business purposes? That's more of a computer science programming perspective. And product, we already spoke about it. It's more like trying to understand the business value and come up with use cases that applies those models. Does it make sense?
Yeah, thank you.
Sure.
I have one question.
Mhm.
So, if at all I were to go towards math and statistics and computer science IT, would that be machine learning? That would be machine learning, right?
Yeah, math and statistics in terms of data science is not just machine learning. It's kind of coming up with, it is machine learning for sure, but it has like much more, like it's a broader base, right? Like you are trying to define the accuracy. You're trying to analyze the. I think Shagan will be in a better position even to talk about the math and statistics and research, because I'm not a researcher myself. But the way I would think of is like, how do we develop more machine learning models? As you said, how do I improve the accuracy? How do I decrease the error rate? How do I do some backpropagation methods, or how do I even develop new models that's beyond machine learning? Like, how do I go into deep learning? Like, deep learning is something we're going to see on a high level today. Like, you have different neural networks. How do I make systems think complex like human being? How do I apply the math into the model that kind of gives the result that we are expecting, right? So that is more of math and statistics. Does it make sense?
Yeah, thank you.
Sure. So this is where I was like trying to make sure you guys like understand the difference between your artificial intelligence, machine learning, and deep learning. So as we said, artificial intelligence is all about replicating human tasks that are programmed to think like humans and mimic their actions. So that's a broader field of artificial intelligence. And then comes your machine learning. Machine learning is a subset of your artificial intelligence where you're going one level deeper to say, don't just automate the task or don't just mimic my task. Try to learn the way I learn, the way baby learns, the way human learns, right? So you're trying to teach the computer to learn similar to how human beings learn. So when you were born and you were raised, there was a particular way you guys learned. We all learned in a way, right? Like you were given a picture of apple, God knows 100 times, 1,000 times, since like A for apple, and then it became A as an apple, and then you have B for ball, and you have all those pictures shown to you, and then so that's how you kind of learn your language, learn your pictures, learn your vocabulary, and then you kept growing, right? So machine learning is the technique, a subset of artificial intelligence that kind of enables or makes an effort to make the computer learn in a way humans learn. With structured data, with unstructured data, supervised learning, unsupervised learning, we are going to see in the second half of the class. But put in a nutshell, you're trying to make computers think and learn like humans. That's machine learning. Your deep learning is one more subset of machine learning where you're not just making them like learn based on like supervision, you're trying to simulate your cognitive thinking ability, the neurons that you have in your brain, like human being, the ability to think complex is something that's unparalleled, right? Like the connections you have in your brain, the relationship you make between objects and whatever you see, whatever you hear, that is unmatchable, and computers are nowhere near it. So deep learning is an effort again to go deep dive into simulating that cognitive ability, the complex neuron connections inside the brain, trying to simulate that. See, one such example in a very layman language is autonomous vehicle, right? Like if you're driving a car and you see thousands of objects in front of you, but your human brain is already capable of understanding and visualizing those objects and seeing whether it is a risk or a non-risk, whether it can be ignored or not ignored. Somebody is walking along the side of your pathway, your mind is not going to be too focused while you're driving because you know he is walking in the pathway. He's not going to cut in front of you. But if there is like sudden something, a debris that's falling in front of you, your mind immediately gets alerted and you brake your car. There's thousands of things that you see at a particular snapshot of second, but can computers do that and simulate? That's the area of like neural networks, deep learning networks, where we are trying to simulate the human brain itself, right? And there is another simple example that I could maybe think of. If I throw you a sentence, try to tell me the answer. This is like just a simple sentence. This is not me, just a simple sentence I'm just throwing out to you. Although born in Italy, I was raised in the US. Despite, I am still fluent at, can you fill in the blanks?
Italian.
Obviously, right? This is your simple machine learning text to speech or natural language processing in a simpler mode would not understand this, because it goes, the moment I said, you kind of, you did the semantics into it, right? You knew that I was talking about being born in Italy, and then I'm talking about despite being raised in the US, I am the fluent at. So you immediately filled in with something. This cognitive ability is what the deep learning neural network does in terms of thinking. This is a simple example. We're thinking much more complex. All your Google searches that you're making, it's not just searching based on the words you put, right? The way you put it, the way you search for it, it's trying to understand the logic and the semantics and trying to put you those articles that it thinks it's relevant. And again, it's a field that keeps on going and going and going in terms of improvisations. But deep learning is all about replicating human brain, keeping those neuron networks and everything intact like human brain, but it's way out into the future. But we are definitely making a lot of progress in deep learning. So put together artificial intelligence, machine learning, and deep learning. That's your hierarchy, or that's a subset you're looking at. Any questions? Okay. So this is something that always amuses me, and you guys can feel free to add in a lot of examples that you think it's relevant, or you can also think about it offline and see where your examples fits in. Some of the fascinating things that AI can do today, right? So one thing is read. When you say read, the example that I could think of is like somebody was talking about bots, right? There is a bot called Summarize bot, which is used in corporates that kind of digest the materials and then reads out to it like in a presentations type, right? Or it's crunches the pages and pages of data and kind of summarizes in a way it's simple and clear enough, right? The other example of Summarize bot is if you're reading like a novel, if you wanted to just get the gist out of the novel, Summarize bot helps you do that. That's one of the place where AI is used. And writing, obviously, like a lot of journals today that you see online and in like papers that are generated with the help of AI. And even your simple, I forgot the name, Grammarly. I don't know if you guys are using it. That's also powered by AI. It just doesn't just translate your grammar. It it does more than just fixing your grammatical errors, right? It kind of gives you some intuitive rephrasing options, rewording options, and all those things. So that's something where AI is used. And facial recognitions, obviously, we know a lot of applications. One is the self-driving cars, sensors that kind of understands and classifies an image as, okay, this is an elephant, this thing, and understands your face and like identifies the facial recognition. All your Google photos and whatever you have in your iPhones and Android, like it, if you see today, it already clubbed, or even if you have different angles of your face, or even if you're in a costume, a Halloween costume, it still asks you, is this person same as this person? And if you say yes, it kind of matches everything. So that's one of the facial recognition that we talk about, and the self-driving cars as well. Hear and understand. One of the coolest thing that I learned about recently is detecting. There is a AI system that detects gunshots and alerts specific agencies to kind of what the risk is and where it's coming from, and whether it's like a non-risky gun or whether it's a risky gun. There is something that's super cool on that area. But to my mind, when I say hear and understand, we have an app that's called Automated Meeting Minutes, listens to the meeting and then like summarizes it in kind of, you don't have to sit and type like, here are the minutes of the meeting. In a corporate world, that's typically a big, at least for me, it's a boring task. Like I have to sit through the meeting and then prepare notes for the meeting and then send it out to people. It's like, here's the meeting minutes. You don't have to do that. There are apps out there that says automatic, like listens to the conversation, understands the semantics, and then let's send out automated meeting minutes. Speak, as somebody had rightly put in, obviously, Alexa, Google Maps, Google Duplex. I don't know if you guys know about Google Duplex. That's something Google is like proud about, and it's still like actively working on. The next slide, we are going to see a Google Duplex in action. So all these are like speaking AI systems, right? It listens to you, it responds to you. It's similar to, it tries to talk like a human, but yeah, it's still, we are getting there, but it's made a lot of progress. Smell, it's in healthcare. There are systems, I don't know too many details about the system by itself, but I know there are applications where even from a human breath, the AI systems, the machines can detect the sickness by smelling your breath. So what kind of issues you're going through, what level of diagnosis it does, that's beyond my understanding, but I know there are applications that does that. I would be happy to know from you guys if you know about it, if you research about it, come back and let me know. Touch, shopping in supermarkets, and then move, autonomous vehicles, drones, understand the emotions, driver monitoring apps. These are like telematic apps. Even in insurance, the farmers insurance that I work in, we are partnered with some telematic app that kind of, it's a driver monitoring behavior, right? You could install that in your computer, in your car, in your dashboard, and then like it kind of monitors your behavior, your language, your braking. Are you braking harsh? Are you like turning swiftly? Are you yawning a lot of times? Are you yelling at somebody? Which means you're actually being distracted, right? So, excuse me. So driver monitoring apps understand your emotions and kind of alert you. And even in all these Tesla and like Mercedes Benz, on a simple note, you can see that if you're driving a car and then like you stopped on a signal, and then the signal opened and then the other car moved in front of you, but you still are on your phone or you're distracted, it immediately shows a message that the car is moving on, like go on, start your engine, right? Like that's one of the simplest way I could also think about basic, but there are much more to it when it comes to autonomous vehicles. Play games, chess, poker, go, whatever you guys are playing today and what we were playing earlier, everything is now automated. It's like computer can play as a partner with you. Debate, there is an IBM project debater that kind of, again, talks like a human. Even the movie that we have, that the robot, the Endiran, or like whatever, in whichever language, whichever name we call it, that's also similar to it's actually AI system basically, right? So it can digest data and it can like debate with you. Visual arts, photography is another area, and then the final thing is like read your mind. I don't know where we are at this point, and it would be hard for me to digest if it can read human beings' mind. But the research is already underway, and God knows, like you guys could be one of those people who develop a software or develop an artificial intelligence system that gives a breakthrough into the human world, like read human mind and then like move on from there. The implications of it, you never know, but the projects and researches are already underway. Any question before we move on to the Google Duplex in action slide? Or you guys think of any other example that you want to add in here? Okay. So let's go over. Have you guys seen this before? Anyone?
No.
No.
Okay. So let's hear from, do you guys know who this guy is?
Probably the Google CEO, whoever that is.
He is the Google CEO, Sundar Pichai, right? So let's hear from him on what he has to do with the Google Duplex. Why is my video not playing? Give me 1 second. You know, when I search share screen, I did not optimize.
You may have to do enable content here, Nitya. Yeah.
Okay, there you go. Thank you.
I think you need to share sound.
Yeah, we can hear it.
You can hear it? Okay, give me 1 second. I think I need to optimize for sound here. Okay, let me know how this sounds. Let me play it for another 10 seconds.
The progress with the assistant. As I said earlier, our vision for our assistant is to help you get things done.
Was it okay? Any better?
Yeah, we can hear it now.
Yeah, we can hear it.
It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now? Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
See how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually we leave there for like upper like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
Again, that was a real call. We have many of these examples where the calls quite don't go as expected, but the assistant understands the context, the nuance. It knew to ask for wait times in this case and handle the interaction gracefully. Look,
So what do you guys think?
That was a good video.
Mm-hmm. So this is more of a semantic switching, right? Like that's what we were talking about. Just don't translate your English in a way system understands. The system is trying to understand the context and the nuance, and then it's able to engage in a very meaningful conversation similar to the way humans do, because it's not always rules driven, right? You you cannot expect every human to be clear in communication. So regardless of how they communicate, if your human brain is able to understand and reciprocate, so need to be the computer brain also. That's where AI is trying to make it step. So, but why AI now? This is like last few minutes we'll be spending on to kind of understand this concept has been there. Even if you go back to like 14th century, 15th century, if you research the concept of this AI was always there, already there. But why do you think it's booming now? Any thoughts?
Well, society runs on electronics, and electronics kind of need AI because AI is like it codes and it allows the electronics to actually function. So since most of society runs on electronics, like we just saw Google Assistant. Like Google Assistant can help plan like meetings, appointments and stuff. So society like kind of runs on electronics, and electronics run on AI. So without AI, you won't have electronics.
That's a good way to look at it, and it's a good point, right? You're talking about the ecosystem, the society, the environment we are in is like very conducive for electronics, and you cannot live without your Alexas or Siris or Google Map. Gone are those days where you have your hard paper map and then you navigate it through. Now without Google Maps, you wouldn't even go like 4 miles away because you still wanted to know what's the easiest way to go there. So environment is one, but actually the big underlying factor, in my opinion, and like in based on the research that we are seeing, it's twofold. One is the big data that we are generating, because AI systems rely on data. More data, more clean data, better learning, and more progress. These days, like imagine the amount of photos that we guys are producing, like imagine the amount of text we are writing on social medias, imagine the amount of articles that are being published. The data in any form, it's like, if you see the graph, that's where is the data boom. It's like an explosion, right? In 2005, you had like around 0.1 zettabyte. So if you guys know I had to Google myself to see what a zettabyte is. Like zettabyte is like 1 zettabyte is 1 trillion gigabytes. Okay, so starting from 0.1 zettabyte in 2005, in 2020, we are approximately at 47 gigabytes. And that's the data that we have produced so far. And with that data, these data, like Google is in very advantageous position because it has almost the entire life history of you, what you're doing, what you're searching, what you're seeing, what you're hearing, everything, right? So it has data of every single person, and that data is being fed to the machine learning models to kind of understand, tune, make it learn, and make it think like this. So the big data is one of the biggest enabler of AI in the current timeline that we are talking about. And so this is a sample of big data, right? Like you guys should be familiar on the reCAPTCHA that we do. There were a lot of, we also contributed to this data. It's like you kind of labeled or picked up images that had signals. You kind of picked up images that had house numbers on top of it, like a street view. When you guys did some login, sign up, and all those things, you did yourself too. And there was a big team, crowdsourced team, that also did this labeling task. Basically, these were the training data sets that were fed into the machine learning model. So the big data in 2011, for instance, you had like 600,000 images, different kinds of elephant, different kinds of purple flowers, different pumpkin carvings. The 2014 ImageNet data had around like 14 million images, right? Like now you can understand the data explosion or the vast amount of data that we have that enables these models to learn faster and predict faster and like think better and more accurately. That's not just that, it's also the computing power. So if you have vast data, can my laptop crunch those data? Absolutely not, right? You need to have the proper hardware to process that, ingest the data, crunch it, and come up with these model executions, right? So the there are huge advances in the hardware itself. The one that you see on the top is a tensor processing unit, and then the other one on the bottom is actually a graphical user interface for video gaming and all those things. So basically, the big data and the big compute has become the enablers of this deep learning, of this AI systems today. And just because these are available, it kind of creates that loop where you said now more and more electronics started applying that, and more devices started using it. Now humans are becoming more accustomed. So it's kind of a loop, but the biggest enablers are the data and the computing power. And this is one of the deep learning, the way the neural networks breaks it and says, oh, if you give an image, how does it recognizes it, right? So from a car, it breaks down. It has hidden layers. You don't know what's happening in the layer until you kind of get deeper into it. But these hidden layers are like the one that breaks into the way it needs to know, and then it applies some kind of a consolidation at the very end. So it's going from left to right, it breaks up, it accumulates again, and then it comes back with an identification saying, hey, this is Audi A7. This is one simple example of how a deep learning represents the world from the data that's given to it. These are, I'm not going to go through it over and again, but
your screen is a little blurry. I can't really see anything. I don't know if this is a problem for me or if this is a problem for everyone, but your
the
screen
prior
is like
slide
kind
or
of
the current slide?
Like
it's
See it
as
properly.
your entire screen.
Okay, these slides are anyway posted on the Agora Engineering Circle page for you. So if you still don't see it, let me know. We will try to fix this slide and resend it back.
Okay, thank you.
So branches of artificial intelligence, we already saw this, like there is robotics, there is speech, neural networks, natural language processing, big data, machine learning, cognitive computing, expert systems. Expert systems are like rule systems. If rule ABC satisfies, do I go with it? Should I offer this? Should I not offer this? Should I classify this person as fraud, not fraud? All those things are those expert systems, like kind of an underwriting guidelines, right? Where is it applied? Again, this is for your offline review. It is almost applied in every single field, and we will go a little bit deeper when we do the second part of the exercise. Also, when we talk about the machine learning models, I have some cool examples of saying where exactly your models are being applied. So let's, unless you have any specific questions here, you can always like take a look offline and come back to us. But it's the way we have divided the slide is like industries on the left, project, what's happening there, like what are the projects that's being they produce in terms of inventories, what kind of progress is happening, promotions in terms of personalizations, recommendations, how these industries are booming, and the product itself, right? The revenue that we are talking about. So take a look at it and let us know for any specific questions. This is from McKinsey's Global Institute Analysis, one of the articles from there. And these slides were actually to be taken by Shubham. Again, he also ended up in an emergency just this morning, very unfortunately, but on a very high level. Again, go over the slides. Basically, it talks in detail. Maybe in next class or like subsequent class, we can ask Shubham to kind of spend some 10 minutes going specifically over this fraud detection use case in finance and fintech. How do we detect frauds using machine learning? These are the slides that talk about it. I would not want to steal the thunder. I will let him go over it at a later point in time. With that, I would want to hand it over to Shagan to again talk through a real life use case and explain his own experience in this artificial intelligence and machine learning field. Any question before we hand it off to him? Okay, I hope you like this first part of the class. Let's take a deeper look into the use cases and examples from Shagan. Over to you, Shagan.
Yeah, thanks, Satya. Let me quickly share my screen. Yeah. You guys can see my screen?
Yeah.
Okay, great. Let me go into presentation mode. Yeah, so good morning, everybody. So I think I'll be repeating a lot of what Nitya mentioned, but I'll go a little deeper into what are the computer vision applications of AI. Just a brief about myself. So I work in the Bay Area in this area of AI and deep learning for a company, NVIDIA. So this company makes GPUs for gaming, but it's also one of the leaders in deep learning and AI applications across the globe. So yeah, so feel free to ask questions as we go. So yeah, a quick introduction, repeating some applications that Nitya mentioned. So deep learning, I mean, she mentioned this is one of the hottest topic in pattern recognition. So we have vision applications. So given an image, it can actually classify that as what the person is. So in this case, you can see these hidden layers actually identify different features of the face, and then they identify the person from an image, from a snapshot of a person. Let me actually, yeah. And then other applications are speech analysis. So I mean, can we convert a speech into text? So this is a typical example of what we just saw in Google Duplex. So these are simple building blocks of things or main applications, use cases that are there. And there are other applications like network security. So we have so much data and transactions over the internet. So there is a lot of AI applications where we want to secure the transactions and so on. Even in medical diagnosis. So I mean, we have models that can look at images and help the doctors identify different kinds of diseases and parts of the images. And lastly, financial markets. So there are lots of applications of deep learning there as well. Moving on. So impact of machine learning is it's very vast. So on the right, I have image of the human brain. In the bottom and the top, these are the neurons that are present in the human brain. So this is the main thought or the motivation behind developing these deep learning models. So they try to mimic the human brain. So they give the computers the ability to analyze, and think just like humans. So humans has these billions and billions of neurons in their human brain. So the deep learning models are trying to develop techniques which are similar to the human brain. So as I earlier said, applications like medical research, financial markets, security. The main idea is helping humans in making or improving the quality of life. Yeah. Yeah. So here I have some examples of computer vision. So things like given an image, classify the edges. So I mean, edges are important because they help analyze the quality of an image or even develop more applications from an image. The second image here, perceiving the depth from an image. So applications such as autonomous vehicles. So you want to know if a car is approaching you, how far is the car, or how far is the object in front of a robot. So these are other applications. Detecting a face from a surveillance camera or other applications. Then there are applications of 3D model generation. So if I give you 100 images of a landmark, can you generate a 3D model of that landmark? So these are all done with different computer vision algorithms and techniques. And we have instance segmentation, where given a scene, can I identify individual objects from it? Then we have like object detection. So given a scene, can I identify different objects. In this case, it drew a bounding box for a person, the dog, the car, the horse, and another person in the back. So these are different things that computer vision gives us, and then these are used to develop applications later on. And over here, I have an application or an example of how the autonomous vehicle looks for different things around the road. So you can see there are pedestrians crossing the road. There is a bike, a person on a bike. There are pedestrians on the sideway. So the car should actually be able to look at the entire surrounding just like the human, and then be able to decide which one is the right path for the car to take. Questions on this slide? Okay. So yeah, some more applications again. Detecting faces from in an image, or detecting faces in a much crowded area. So this is an like example of this was the Boston Marathon, where they have surveillance cameras looking at all the persons and identifying them, like which is the person who is registered and who are not registered, and so on. Applications here, and over here we have remote sensing example, where we have a image of a neighborhood from a airplane, and then the task was to identify different cars and then identify parking spots and so on. So lots of use cases here. And then this is the autonomous vehicle. Again, we have talked about it. Lots of medical applications, augmented reality, virtual reality applications, and then we have some robotic interaction applications as well. So yeah, so let's actually dive into a couple of demos, so that will make it a little more interactive and like give you a chance to look at. So I have like three examples here. So this is an image classification example. So these are images from the ImageNet data that Nitya showed earlier in the presentation. So what it does is it takes an image. So let me click on any one of these images. Let's say this panda image, and when I hit run, so what it does is it passes this image through this entire deep learning model. So this model has like millions and millions of neurons, just like the human brain, and it passes these images, and then it tries to classify what this image, the object, is presented in that image. So in this case, it says that this is a giant panda with a and it has a confidence pretty high. Out of 1, it has a confidence of 0.99 in saying that this is in fact a giant panda. And so this is a typical example of what these deep learning models can do. So you see, we pass in another image. It says, okay, this is a goldfish with a, and it's pretty confident there. So yeah, more examples here. So it can classify the type of the monkey in this example here. So imagine this model is actually trained on millions and millions of images with thousands of categories. So this is a typical example of where deep learning models can get better at doing things in a way where they can beat humans. So there is a human capacity of number of objects the human can classify, but these deep learning models are getting better at doing that specific task. Yeah, so that's one. Then I have another example here. Let's see. So this is another very interesting case where we can actually summarize an image with a sentence. So let's pick any one of them. Let's pick this guy. So I clicked on that horse image, and we can see so if I hit submit, so it will actually go ahead and try to classify the objects, and then form a natural language sentence from that for that image that is describing the this image here. So we can see one of the sentences it generated was a group of people riding horses on a beach, a couple of people riding on the back of horses. So these are pretty awesome networks, which actually just given this image can generate a sentence which is like which can be read and understood by a human being. So that's pretty this is one of the state-of-the-art technologies and understanding images and describing them with text. So imagine like you have like millions and billions of images on the internet, and if you want to do a Google search, so these are the text, these are the important words that Google uses to basically index these images. So when you search for, let's say, people riding on a back of horses, like in your Google search, so it might end up with such an image because it has used such networks to index these images. Let's look at another example here. Let's look at this guy. So yeah, so we will see here. So we see how it actually generates a human sentence, and so it looks like this image. It tries to form this sentence using this. So a surfer is riding a wave in the ocean. So these are pretty accurate sentence. And just bear in mind that these models are not just trained on images. So they have looked at lots and lots of text. So some of these models are trained on the entire corpus from Wikipedia. So imagine a model that has learned from the entire Wikipedia, and how smart that would be. So that's how like data hungry and like enormous these deep learning models are. So they look at all the text present ever in the internet, and that's how they learn. They read from like tens of thousands of books, novels. They read the entire Wikipedia. They read lots of books, and then they learn, okay, the nuances of English language. So should the sentence start with an A or a D or an, and so on. So I'm trying to find the example of like an article here, but maybe not. So but you can see it. So given this image, it found these important words like person, surf, and wave, maybe ocean, and then it tried to tie those keywords in the form of an English sentence because it has seen like so many English sentences. So that's the main idea behind this. And you can also imagine the kinds of applications this would bring in the actual use cases. Quick question on this? Okay, let's go to another very neat example here. Yeah, so this is an example where you can actually colorize an image. So you can see like so these are like 4 examples that they had, and so this is a black and white image, and it can color it based on the training it has seen. So these models are trained on pairs of images. So it has seen how a black and white image is and how a color version of it would look like. So, and then given a black and white image, it can try to put in color. So like all the old photographs, so we can use such a model to actually put color to them. Pretty neat applications, right? Any other applications that you guys can think of that like that are not listed in like in these things? Any computer vision applications? Okay, let's go back to the slides then. So yeah, so this, oops, yes.
Yeah, I'm trying the site, but when I want a beam, it's just crashed.
Oh, did it? Let me go there again. Like this website right here.
Yeah.
So you were trying beam as in this number of beams?
Yeah, I tried like 10,000. I wanted 10,000 beams.
I would say go with the server. So yeah, this is like a free server that they have. So they may not actually support like, because the number of beams increases the number of sentences it has to generate. I mean, it's trying to do something when I did 10. So let's see. It's trying to form 10 sentences. So beam is basically the number of like at each instance how many different words it would try to form. So when it got the word A, it would have gotten 10 different possibilities for the second word, and then for each of the second word, it would get 10 more possibilities, so it's 100. So it kind of adds up exponentially.
Okay, I
Yeah.
got it to work again.
Okay, yeah. I mean, these are nice things to play with. You will get an idea of what these deep learning models are used for, and then I mean, as you get interested, these are good things to dive deeper in your studies and look for other interests there. Yeah.
Does end mean the end of the sentence?
End means the sentence ended. Yeah. So that's how these deep learning models, like, because I mean, as humans, we know, okay, when this sentence ended, so the machine needs to be trained that, okay, this is where the sentence has to is finished, has to end. I mean, the purpose of the sentence and the meaning of the image is now captured, and you should stop predicting any more words. So that's like the end there. Some models also have a start token here, like the sentence should start now, but this particular example is going away with. Yeah. Okay, let's go back to the slides. Present this. Okay, yeah. So coming back to like an overview of computer vision, so we have seen lots of applications here. So applications in optics, robotics, like image processing, signal processing, geometry. Machine learning is tied up with computer vision. So these, I mean, all these fields are very much interlinked. So this is what this image is actually trying to convey. That you may work in mechanical engineering, you may work with civil engineering, but like there is a vision aspect to it where you can tie that with like vision, computer vision and machine vision use cases. So let's say you are a mechanical engineer and you are working in developing these car parts, for example, like car engines and so on. So you can use a computer vision model or a computer vision technique to find defections, like if a certain product you manufactured is defective. So these vision applications are present in all different fields there. And then likewise, the machine learning field in general is also associated with so many other areas as well. So if you're working in the computer vision, you can develop a machine learning model to do your computer vision problem. If you are working in NLP, you can develop a machine learning model to do your NLP, and so on. So all these fields are very interlinked. So like finding a distinct definition for one of them is very, very hard. So that's why people like you will hardly find people working on a single blob here. So if you find a person working in data science, it's likely that the person is also working with machine learning, also like using statistics, also using pattern recognition, mathematics, and so on. So these fields are very tightly linked to each other. So I mean, these are some things you should keep in mind when choosing your career as well. That if you want to work with, let's say robotics, that's a very neat career choice. So you will have to be involved with a lot of other areas as well, like geometry. You need to understand the world geometry, how the robot sees the world in 3-dimensional. So that's a very important aspect to it. And to do that, you will need some background in computer vision or some background in machine learning. So that's how these fields are interlinked. Questions on this? Okay. So here I have more examples of like kinds of vision tasks. So the most simple one is like a classification task. So this is like the example or the demo that we saw earlier, that given an image, I want to classify that whether that image is a cat, a dog, a rat, or whatever. So this is like the most simple application of a deep learning model. Then comes the second stage. So I just don't want to classify it. I want to localize it as well. I want to find the box which has the cat as well. So this is like one step ahead of classification. So imagine this like this application in autonomous driving. So when the car is actually looking at the road, you just don't want to say that, okay, there is a car ahead. You want to localize that car as well. Is the car on my lane? Is the car on the other lane? Or is the pedestrian on the sideway, or is the pedestrian walking on the road? So you want to like not just classify but localize the object of interest as well. And then come object detection. So you have multiple objects here. So you can have like different objects here. You can have tens of cars in the scene for an autonomous vehicle, and you want to make sure you are able to classify and localize each of them. And then lastly, there is instant segmentation. So like a loose box would not do. You want to like tightly recognize the object and the part of the image it is covering. So these are like some basic use cases of deep learning and like the vision applications that are there. So yeah, and I mean, this is an example with like cute animals, but imagine this is in autonomous vehicles and like so many other use cases out there. Okay, so why is this task so hard? So that's a very like usual question that we hear. I mean, so when a human sees this image, I mean, we like our brain is trained to process like over time that, okay, this has like so much fur, it has two legs in the front, it has this face, so this is a cat. So for us it's pretty normal, but what the computer sees, it's just a grid of numbers, right? I mean, so when you write your Python program and read this image into the Python program, so this is what the computer would see. So you would want your program to find meaning in this pattern of numbers. So you want to find what are the edges here. So if I mean like what kinds of body parts are represented by these grid of numbers, what are the edges, what are different things, and then out of all that information find some meaning and then classify that as a cat, dog, hat, or a mug in this case. So that's why it's such a like a difficult task for the computers. So even in the earlier example that we were seeing, the demo example of the giant panda and the goldfish, so we were actually feeding the computer an image, but the computer was actually getting this grid of numbers, and then it was trying to find meaning from this array of numbers. So that's where the Python skills that you guys are learning will come very handy, because when you load an image into your Python program, so this is how the image looks like, and then you want to train a model or find techniques that can identify patterns and data from this to be able to perform a task. And then it's not just the numbers. So there are lots of variations there as well. So viewpoint variation. So I mean, imagine you have a cat image. I mean, you can look at it from the top, from the side, from the front, and I mean there are so many like ways, thousands of ways you can view a cat, but and you want your model to perform well in all of them. Other challenges are like illumination conditions. So you can see the cat in dark light, in shadows, in sunlight. So that all brings in more and more difficulties for the model. Then scale variations. So you can have a small cat, a large cat, and so on. So you want to be able to distinguish that. Deformation. So the cat can be not necessarily be standing or sitting. It can be in so many other forms. It can be mixed with the background. So it's hard to distinguish a unique object with the background. Occluded. So you can only see parts of the object. And then lastly, interclass variations. So you can have thousands and thousands of cat categories. So in this example, we see different kinds of chairs. So it's I mean, for humans, it's easy to say that, okay, this is a chair, but for a machine learning model to classify them as a chair, that's a very big task. Okay. So why is this getting more and more important? So Nitya did talk about this earlier. I have some more statistics on the same idea behind it. So the amount of web data available nowadays, it's enormous. So these are some statistics. So on Instagram, every day 100 million images and photos and videos are posted. So you can imagine the scale of data available as each day passes. On YouTube, 300 hours of video is uploaded every minute. So as we speak, thousands and thousands of hours of new video data is already uploaded to YouTube. So you need models and systems that can actually process this data and find some meaning from it. So that's where like these deep learning techniques are getting more and more popular and useful. Yeah. Yeah, autonomous vehicles. So we have talked about this earlier. So yeah, this is one of the like most popular application right now. I mean, it has so many challenges because I mean, you want to make sure if a computer is driving a car and you are sitting on the passenger seat, the car is doing what a human should do. So it's not just looking ahead, but it's making smart decisions to make you safe and comfortable. So that's where autonomous driving is a very important application.
And that's why it's not possible to watch everything on YouTube too.
Exactly.
Every day for some 320, 200 some, like a ton of videos uploaded.
Exactly. I mean, so that's why you need these deep learning models and like high processing engines that can parse this data much quickly than how a human would do, and then be able to recommend you a video. So if you have 300 hours of video uploaded every minute, so you want the computer to recommend you the best one that you may like. So that's where these deep learning models come into play. Even applications such as Netflix. So based on your watching history, your likes and dislikes, it tries to recommend you a movie or a video based on like after processing so much data. Other applications are like when you go shopping on Amazon. So I mean, it looks at what you have searched for. It looks at your web history. It looks at your purchase history, and then recommends you, okay, I mean, this is a new product, you might like it. This is a new brand, you want to try it. So that's how these deep learning techniques are getting useful in our day-to-day lives. Yeah, autonomous vehicles is there, and then another application is robotics. So a few weeks ago, we heard about the robot landing on the Mars. So I mean, that's a very useful and like important application of robotics. And other applications are like in manufacturing. You want the manufacturing factories to be more efficient to help the humans. So that's where these robotic applications are getting used. Augmented and virtual reality. So we heard earlier people like gaming. So I mean, AR and VR, which is augmented reality and virtual reality, are another cool applications of computer vision and deep learning. So I mean, you want to find smart ways where people can interact with the virtual environment. So in this case, you can have like you can be playing games in a virtual world. You can add like things to the like virtual things to the real world to interact with it. So these are more applications of computer vision and artificial intelligence. And then there are like more important applications such as science and medicine. So in medical imaging, you can give an image of a tumor to a system, and then it can classify it for you whether it's a benign or a malignant tumor. So this can help the doctors in like detecting a disease much sooner and help save lives. So you can see how useful this is. Galaxy classification. So astronomers have used these models in galaxy classification and saving their time. Whale recognition. So there was a challenge back in 2014 or 15 where they had like images of the ocean, and the task was to classify whales, and that would help us study climate change patterns and what patterns are, or what areas the whales are actually going towards. So these are like important areas where deep learning is also being used. So this is just like a small list that I like kind of curated, but I mean, this is like the list where deep learning and artificial intelligence and computer vision is being used. It's like it's never ending. And so why are these things getting popular now? I mean, why is it a buzzword now? So I stole this slide from a MIT course going on, like it's active right now. But I mean, they talk about three main reasons that this thing has become popular. One is the big data, so the availability of larger data sets, the availability of data over the web. So that's the number one thing that we saw. So much data is there, so we can train models that can extract patterns and useful information from this. The second is the hardware. So we have these GPUs coming in from like big companies like Nvidia, AMD, Google. So they help in processing all this enormous data. And then lastly, the software. So we have lots of tools and models available to us at our disposal that we can train these data on this hardware to basically generate some useful information out of it. So in this course, what you have been learning, it's mostly towards the third point here. So you are learning these programming language to help you understand these toolboxes and techniques. And then once you have those skills, I think you will be one step closer towards using the data in the right hardware to call yourself a data scientist, or a machine learning engineer, or a mathematician, or even a gamer. I mean, gamers are very good resources for deep learning people. So yeah, I mean, so lots of career choices here, but like getting some information or some background on deep learning and AI, I think this is a very good time to be there. So I mean, this slide just talks about like the progress that we have so far. So here we have like image classification on this large ImageNet challenge, and the bars here reflect the errors. So you can see the errors are actually going down over the years. So in 2010, we had an error of 28%, 2011, 25%. Then we saw a big jump in the improvement. So in 2012, the deep learning came in and we saw a big jump here. So the errors went down further and further. And the last row here, so this is the last column here. So this is something I want you to like look at. So this is the human accuracy that was measured. So the human error is around 5%. And you can see in like 2015, we started to beat that. So in this task of ImageNet image classification, the computers are actually getting better than humans. So this slide doesn't say that AI has gotten smarter than humans in no way, but for certain tasks, definitely the algorithms, the systems, the techniques are getting better, and they are starting to beat humans at these tasks. And imagine these tasks are not easy. I mean, this particular challenge has 1,000 categories of objects, and the human is actually go in, look at an image and say, okay, this is what breed of a dog that is. I mean, humans are susceptible to make errors there, and whereas machines, they are like, I mean, they'll just learn features, distinguish different features and parts of the image, and be able to classify that correctly. So these are like very difficult tasks for humans for sure, but machines are getting better at that too. Question on this? Any comments? Okay, I don't think I have like much slides left. Just like one or two more. So this image basically gives a brief summary of what we have looked at. So this talks about these 5 different points. The first is perception, how the deep learning models or these systems gather data. So the computers perceive the world using sensors. So these can be camera sensors, sound sensors, audio sensors, even touch sensors, smell sensors. So all this information is actually fed to the systems and deep learning models using sensors. The second is representation and learning. So these agents maintain representation of the world and use them for reasoning. So they look at data and basically learn from representations. Third is how do they learn from this data? So they look for patterns, and basically just like humans do, they try to learn from like enormous amounts of data. The fourth is natural interaction. So the intelligent agents require many kinds of knowledge to interact with the humans naturally. So the example that we saw of the Google duplex, so that's like how does the computer naturally interact with the human? So that's a very good example of that. And lastly, the center point, the societal impact. So AI can have both negative and positive impact to the society. And it's up to us, the future designers and like the AI practitioners, to make sure that it's actually impacting the society in a positive way rather than in a negative way. So I mean, I'll give a negative example about the example of a negative impact to the society with AI. So the advent of fake news and fake images and so on. So that has hit hard to the news and the world. So that's all given by AI, and that's like a negative impact. And on the other side, there are AI and deep learning ways to counter that as well. So there are like both good and bad in this field as well. And I think this is my last slide. So it's, I mean, this is just just an example from a paper from this year, 2021, and it's not always about science. Sometimes it's about fun as well. So here we give it a text prompt, and it tries to generate images from the text prompt. So the bottom one, an armchair in the shape of an avocado, an armchair imitating an avocado. So the model actually generated these nice looking images. So it's not just always about science and engineering and technology, but sometimes it's about fun as well. So the AI can generate these beautiful, cute looking images for us to like look and enjoy as well. I think, yeah, that's all I had. So I think question on this. Okay.
Avocado chair.
It was a very great presentation, Shagan. I particularly enjoyed the societal impact as well, because it is for the students, they need to know the positive and negative impact, especially because if you're studying so much of the human behavior, like privacy is a bigger ethical implications, right?
Exactly.
You can go analyzing a person's likes and dislikes. I know you're recommending well, but in the process, you're actually studying me more than what I know about myself. So
exactly.
Implication for sure.
Yeah. I think that's where these big companies are playing an important role, that they have to make a fine distinction between what data is actually important to make sure the person's information is private, as well as being able to positively help them as well. So
right. Guys, any questions before we break out for like 10 minutes? Okay, just two questions to confirm your understanding. Shagan was talking about NLP. He referred as NLP in one of his slides. Do you guys know what NLP is?
Is it neuro-linguistic programming?
A good guess though. Anyone?
Close, but not there yet.
Yeah.
I think I know.
Go ahead.
Natural language processing.
Absolutely.
Yeah.
NLP is natural language processing, and he also mentioned why AI now. Can you tell me 2 points why AI now? What's the buzz about AI now? 2 important points. Anybody?
Robotics.
Yeah, why is it booming now, basically? Thoughts on why AI has become so popular now?
Because a lot of people use electronics.
And then, yeah.
Because it has a smaller error rate than humans.
Yep. Yeah. And all these are enabled by the big data that's available and the good amount of processing and computing power that's available in the market today. Those are the enablers, and the ones that you guys are mentioning are correct. It's more of the results, right? Any other questions? Yep, the big data. So remember the slide and somebody asks you why AI now, and the data, improvement in the hardware, and improved tools and techniques on the software and programming side.
Yeah, I have a question.
Go ahead.
What's a neural network?
Vishagan, you wanted to answer that? This question is what a neural network is. Shagan, are you on mute?
Unmute. Yeah. Sorry. Could you repeat the question? I didn't catch that.
What is a neural network?
Oh yeah. So neural network is like an algorithm which trains on data. So I'll show. I don't know if I have an example here. Yeah. I mean this image right here. So this is a typical neural network which takes in an input and it processes the input and with some hidden layers, and then it basically presents you with certain prediction. So neural network is like an algorithm that learns on different inputs or parts of the data to basically learn features and patterns from it.
Okay, I understand.
It's a mathematical model in other, like in some way as well.
Okay, if there are no more questions, how about we just take 10 minutes break and then have another 15-minute presentation of some of the machine learning algorithm that Ayan Shagan was talking about in terms of what is a supervised learning. Like it's more into the third part. It's the model, machine learning model that Shagan was presenting. It's the data was one, hardware was one, and the model was one, right? So you will definitely be learning more about the models through Karthik. So our intention is just to present you with the introduction of those models in a very high level way. And I also have a small game for you to play along in terms of understanding what a training and a testing means. Should take about like 15-20 minutes at the maximum. So it's 11:08 our time here. So let's regroup at 11:18 and then we'll get it started. We'll still be around if you have any questions, but just a break, mental break to kind of digest all the data that we were talking about. Any questions before we begin the next part of the lecture? Okay. Are you guys back, by the way, or I'm just talking to myself?
We're back, or at least I am.
Perfect, thank you. Okay, let's get started with, let me know if you're seeing my screen. Let me get the, so for the next 15-20 minutes, these are the ones you're going to learn really deep with Karthik and rest of the lecturers. Again, my goal is to just introduce you to data science and take you through the high-level algorithms that you might be learning shortly from now. So you kind of exposed now at a conceptual level, and then you would go on at a practical level. So quick coverage of agenda, why data science, what is a supervised and unsupervised learning, some of the key terminologies that you would be using, and what is a training procedure, what is a testing procedure. So what is a training data set and a testing data set, not just conceptually, but through a small game that I always love playing with my little one. And I also introduced that to my daughter when she was like second grader or third grader, that kind of re-emphasized the concept of training and test in a very natural, enjoyable, small game, right? So that's what we're gonna do. And let's get started. So why data science? What is data science? Now Nitya and Shagan spoke about artificial intelligence, machine learning, and then deep learning. Now, what the hell is this data science now? And pardon for my language, I just like, if it's too confusing to you, you're on the same boat with all of us. Data science is basically an application of machine learning to real world problems. That's it. It's just an art and science of applying the machine learning, whatever we just spoke about, the training the machines to learn like us. That art, that science is called data science, basically. Why data science? One, it's time consuming. Otherwise, if you have to do it programmatically, but in data science, it's more time saving. When I say time saving, what does it mean? So let's say you're thrown an example or task of correcting grammar errors, spelling mistakes in a particular language, say English. And I ask you to write a program. So if I give you a sentence, it should correct all the spelling errors in this particular sentence. Write a program for that. So you could potentially take weeks and weeks and go some kind of tree concept, some kind of decision constructs, and you kind of do all those if else programming and everything. And then after weeks of effort, you could say, well, here is a program that could fix the spelling mistakes, right? But it is much more time efficient if you just take off the shelf ML machine learning model, and throw it some examples like these are all the words and spellings of English. That is right spelling and right correction. Just throw all the examples to that, and the machine learning model would know these are the right spelling and right grammar for this language. And then the moment you feed in real data, like a real sentence, it will just apply the corrections. Hey, based on my dictionary, this is the spelling, and yours has this, and this is the right spelling. So it'll correct it even less than half the time that we are talking about. You don't need weeks and weeks of programming for that. So that way it's very time efficient and time saving, customizable. Like after weeks, I tell you, it's like, okay, take a week break and then come back and extend the same logic to Spanish and do it same for Italian and German. You're going to take again weeks and weeks because the language itself is new, right? But here, you don't have to do anything. Again, feed in some examples of Italian language or like Spanish words and spellings and whatever it is. And then the same model, whatever you use for English, now it's being trained on the Spanish language, and then it's ready to use for Spanish error correction, the language error correction. So it's very customizable and scalable in that sense, and ability to model techniques that are otherwise unprogrammable, right? So if I tell you that, okay, look at the image of the dog and tell its emotions, whether it's happy or like grumpy or whatever it is. Can you write a program for that? It's quite hard. And understanding the sentiments of a person or whatever it is, like there are so many things that are non-programmable. Just your brain says, I know it is that way, but how do I put it in program, right? How do I put it in Python, or how do I put in C++? There is just no way to put that. Those things are better represented through the machine learning models, because as we said, machine learning or the artificial intelligence itself is a replication of the human brain, the human behavior, cognitive behavior, and the learning process. So it is able to model techniques that are otherwise very unprogrammable. So remember the advantages of data science: time efficient, customizable, scalable, and ability to give you create something that has otherwise not just programmatic. It actually there is a shift in mindset itself. You're more thinking from just that logical programming to a science-based programming as well. So there is a lot of mindset shift as well. That being said, this is one of the key areas of significance why data science is very popular these days, because it reduces programming effort and saves a lot of cost as well, because it's reusable. Now, there is a lot of data in there. This is where we'll spend most of the time for the second half, but I'll try to keep it super simple and super high level. So on the top, you have the machine learning models, right? Like now you wanted, what is a machine learning model? At a broader level, it's classified into two types: supervised, unsupervised. So supervised is very similar to how we were all trained as a baby, or like we are even being trained now, right? As Shagan speak, I learned a lot of things from him. As I speak, you kind of get some insights about the machine learning and artificial intelligence and so on and so forth. So it's very supervised in the sense we are telling you this is what it is. We showed you some examples. Show a data, show a figure of an apple and say this is apple. Baby learns it's an apple. Show this is a car and it says it learns it's a car. And cause and effect, right? Touch a fire, you get burned. Like they may not touch it, but you can always see you get a boo-boo. You touch a fire. Maybe it learns practically at some point, like touch and feels, and then it realizes, the brain realizes I shouldn't do it next time. You fall, you get hurt. Supervised is all about feeding the data, like trained data, like lots of data, labeled data, saying this is panda, this is camel, this is apple, and then system based on that will learn to predict or label data that it has never seen before. So you showed an image of a small camel and it said camel, and later you're showing a bigger camel. The baby will be able to say it's a camel. End of the day, maybe it doesn't know it's like small camel or big camel. It's camel. It doesn't matter. It's a camel, right? So it's an unseen data, even if you show a bigger camel picture. Similarly, machine learning systems get trained on a trained data, training data, and starts predicting and labeling on unseen data or a new data. And it's also in data science world, it's called a test data. So supervised learning is where you fed into the system, you threw in a bunch of labeled examples, which we are going to see in a moment, and say, these are all the data and these are all the labels for that. I'll tell you what a label is basically. And on the other side of the machine learning, you have unsupervised data. So not everything in the world is represented by just learning. You cannot like expect somebody to keep teaching you, but the human brain is already capable of forming some patterns even on the objects that you don't know the name of. Like it kind of, you bring in like a 12-year girl and a 14-year boy and then like 16-year girl again, and then based on your interactions with them and based on your discussions with them, at some point you might not know everything about them, but you will kind of start forming a group or a pattern or a common theme between them. That is an unsupervised learning. It's kind of unsupervised is all about like grouping, clustering, and then saying this cluster exhibits a common behavior. Now, I don't know what the cluster is. There could be a lot of other differences between those clusters, but I see a common behavior X. I don't know the common, but there is a common behavior, which is X for this group of customers. So that is an unsupervised learning. So you do not teach the machine learning models what it is. You don't tell them it's a camel. You don't tell them it's an apple. You don't tell them anything, but you just feed in a bunch of examples, unlabeled examples, and it starts using those the deep learning techniques that it's being trained on. It kind of classifies and say, okay, you don't tell me what it is, but I can see that there is a pattern. This group, this pattern, this group, this. It just classifies and keeps it. Maybe I just wanted to show you a pictorial representation of that's unsupervised learning. So if you can still see my screen. So this is the way.
I'm trying to listen now.
Is there any question? I hear somebody talk. Okay, can you see my screen now?
No, we can't.
No.
Okay.
Will you share the slide presentation, like at a link?
I guess it's already posted, but I'll leave it to Kalyan and Pawan to answer that. Let me check at the end of the class and then we'll see. Did I hear you like you wanted the slides to be posted?
Yes.
Yeah, it'll be available. So you guys are able to see my screen now, right?
Yeah.
So this is on the right side, what you have is an unsupervised learning. On the left side, you have a supervised learning. So basically, Supervised can predict information on a given set of x, what is y. So if you think about your linear equations, for examples, right, y equal to mx plus b, y equal to m1 x1, m2 x2, m3 x3. So if I give you x as input, it can tell you y. Or if I tell you, if I ask you whether this mail is spam or non-spam, whether it's a cat or non-cat, or what is the probability of A winning this basketball game, all these are predictions and classifications. They supervised learning would be able to do, but unsupervised learning is more about clustering. It just forms a group. It just forms a pattern based on the random examples that you gave. And at this point, you don't have to confuse you so much, but supervised is like where there is a human intervention, there is a trained data, but it's unsupervised, like you don't teach the model how to learn, you just throw in some examples and let the machines figure it out by itself, try to come up with a pattern and a grouping. That's supervised and unsupervised. So going back to our slides, within supervised, you have this regression and you have classification model. Again, this is not just the models. I'm just picking up some linear models to keep it super simple. Regression is, some of you will know what a regression equation is, I guess, based on your high class mathematics already. The linear equation, the regression equations. So it's very simple, right? You have n input variables and you have weights assigned, or like slope assigned, and you have a prediction like y equal to mx plus b, or like in other word, in machine learning world, we will say y equal to w1 x1 plus w2 x2 plus w3 x3. What are these x1 x2 x3 means? x1 x2 x3 are like input variables. Given that input variable and given a factor for that each of those input variable, what is my final value, what is my y? So that is one of the models. That's a prediction, and it has a lot of use cases which we'll be seeing in a moment. One of the examples is the house price predictors. How many of you have seen Zillow? A Zestimate? Do you guys know what a Zestimate is? So if you don't know what a Zestimate is, try to like Google later on, like Zillow estimate. I think I have a picture of Zillow estimate as well. So if I need to know a 1,500 square foot apartment in the area of Los Angeles with a pool, and with a good neighborhood school, within a proper school district, what it would cost. So I put in a lot of variables in there, right? Like I told the location as Los Angeles, I told with pool, and I told with a good school district, and square foot. With these, my system should be able to predict the house price would be so and so. So this is an example of house. Just give me 1 second, please. Sorry, that was my little one just waking up to kind of say good morning. So this is regression. House price predictor is one of the regression. Like, did I make sense when you say predicting a house based on a bunch of variables? The second one is probability of winning a game. So like I threw a dice, what is my probability that I'm gonna get 1, I'm gonna get 2? This is very simply put, but there are a lot of use cases. We also call it like a logistic regression or a classification model. One of the example is what Shagan already spoke about, right? So given the set of characteristics in from your body analysis, whether that particular tumor is a cancer tumor, or it's like benign, or it's cancerous, right? So that's a classification. How that classification is based on all your input variables, and say the probability of it being a cancer, if it is like 0.9, we keep the threshold and say, okay, for this particular 0.9 threshold, meaning it's a high probability that it is going to be cancerous. So I'm going to classify this as cancerous, basically. The logistic regression is all about probability. It always has a value between 0 and 1. The regression model on the house prediction, it has some discrete values, right? Like given X, what's my value Y? It has a range of values, but your probability value from a logistic regression model, it's only gonna give you a value as in any probability, right? As you know, mathematics of probability states that it can have a value of absolute not probable, which is 0, and absolutely probable, which is 1. So the probability, logistic regression models gives you the probability of any event happening, basically. And then if you extend that probability into a classification, that's where your classification model comes in, which is more realistic, whether it's cancerous, non-cancerous, email is a spam or not spam, all those models. So basically how you're training these models is through your supervised mechanism. Again, you, for example, if you're asking a house prediction, a model to predict the house, it cannot just predict the house value, right? But you fed it like thousands and millions of data from Los Angeles, data from San Francisco area, data from apartments, data from based on pool, non-pool, good neighborhood, good, not so good school district. You fed in a lot of data, and you also fed the price of each of those houses. You did not just say these are the X variables. You also said for these X variables, the value of the house was A. For these next set of variable, the values B. So you kind of fed all those input variables, and you also fed the output value, the price value for that. From that, the data, the machine learning model will ingest those data, and it will tune itself to say, okay, now I know if it comes from these ABC input data, I know to predict Y as an output variable. And you can test it by putting in a new data that it has never seen before and see if it is predicting it well. And if it's not predicting well, you go back and tweak the model. This is a very supervised learning. It's like baby learning. You teach it, you test it, assessments. If the assessment is poor, you go back and retrain it. That's a supervised model. Any questions before I go to the unsupervised? And unsupervised is most like a deep learning or a classification model. So you don't have to go deep thinking or confusing yourself. As I said, it's more for customer segmentations, basically classifying or identifying a pattern. So if I know to find a common theme of customers of particular demographics, say 18 years, 13 years to 18 years have this kind of a taste, and like 20 years plus have this kind of a taste, and 40 years have this. If grouping based on a demographic is one of the patterns that I could think of, this is more useful in marketing because I know now based on this group, if a new person comes in, if the new person fits into this group, like say 13 to 18 years, I know what to promote to them. That happens at Amazon all the time, right? Like, because you purchase this, there would be other customers who also purchased something else. And because the system thinks that you might be belonging to that group of customers based on the classification that it did, it is trying to recommend the products that the other customer purchased for you. So this is more like a marketing technique, like you have classifications and personalizations and promotions. That's more unsupervised, where you let the system find a common theme and group the people. Moving on. So I just wanted to introduce you some key terminologies with the one that we just spoke about on a regression model, right? So at the bottom, if you see, this is the equation that I have. I want to predict the house price, and price, to keep it super simple, I just put two variables today, location and square foot. What is the percentage weights? What is the factor I'm giving for location? And what is the factor I'm giving for square foot? It's something for the model to pick it up based on all the input data you see. So if it is a Los Angeles location, I'm giving a higher preference, higher weightage to it because it's going to be expensive. But if it's going to be a little suburban, it is a little bit cheaper than Los Angeles area. Square foot, again, if it's 1,500, I need to give it some weights in conjunction with the location, right? So if this is the equation that I am feeding into, that I'm kind of using to predict the weights, couple of terminologies here to begin with from the top. Label. Label is the Y value. In our case, can you tell me what is the Y value? What is the label here? Can anybody take a guess?
The price?
The price. Price is the predicted thing. That's the label. That's the Y value. And what would be the features?
The cities,
What is it?
the place where you're trying to buy it.
Location and
Area?
square foot. Yes. So the feature are these input variables that we are feeding into the system. Model is the relationship between the input and output. What is the model here? This is just the equation. The price is this one plus this two. The model that we are coming up is actually the relationship between the label and the feature. Inference is actually testing your model on new examples. So you give an unseen example to the model. What is the prediction it is making? That's inference, right? What are you inferring from a newer value? And data set, it's just a huge amount of data that you give it both for training, validation, and testing purposes. Some of the terminologies, definitely you're going to see all these things in a deeper way, but this is just to introduce you in relationship to the regression equation that we already know. So you have the label, feature, model, inference, data set, and weights. Any questions here? Okay. So there's some, just like we had, I know there is a lot of data that we already spoke about. So this is just again like a real world example. In the deck that I shared, I would have also given you the link from which I took this. This is a personalization example. So McD invested and acquired an AI company trying to automate the drive-through, basically. So if you are driving through, like if your dad is driving through, your mom is driving through, the intention is to personalize depending on who is pulling over. So if the system knows I'm a vegetarian or I don't eat meat, it's not going to even promote anything on the double cheeseburger or the beef patty or whatever it is. It's going to, or if it knows I'm more of a sugar person, like I have a sweet tooth, it's going to emphasis or like project more of the desserts or like treats that they have in their system, right? So this is one of the coolest personalization technique for which McD acquired the AI company. Again, how it's going to identify the customer, all these things is left for the research, like maybe with the face recognition or maybe with they will ask you to input your membership number, whatever it is, right? But there should be a process to identify you. And once they identify, the system will promote things that it thinks you would like it. This is another real world application, which is the Zillow, as I told. It's a real estate price estimator. So you can see the rental value, you can see the house price value, you can always see this estimate history on the right. I don't know if you're able to see it clearly, but it is the estimate that it thinks to be the value of the house, depending on all the parameters that we spoke, whether it's furnished or like it has garage, which it has like flooring done, renovated, plumbing done, whatever it is, thousands and thousands of variables. This is something you guys will automatically know because I'm pretty sure you guys have like your own profile on Netflix. So like in my household, I have a profile, my daughter has a profile, my little one has another profile. So depending on who is watching, it promotes content for that user. Not just it promotes content, it also, even if there are the same movie that it thinks it needs to recommend for both me and my daughter. Maybe we both love the same movie. The system thinks it's applicable. The way it does also very intelligently is it produces different thumbnail depending on who the user is. So if you see the circled one, the Godfather, it has two different images. User one would have seen that image because the system thinks based on its prior learning about the user that this would be more appealing thumbnail or like a trailer snapshot for this user one, and for user two, maybe it thinks the other picture that is more relevant and more appealing. So it does not just recommend personalizing the movie that you need to see, it is also personalizing the way you see the movie trailer or the snapshot to be. So Netflix is completely into AI. It has invested heavily on personalizations and recommendations. So it's something for you to go back and see how Netflix is using AI to improve its product offerings. So as I said, we are at the end of the slide. Let's just do, as in my prior slides, I spoke about training data set and a test data set, and I promised you I'll go through a small game. So let's just take 2 minutes to go over the game and see what it's all about. You guys are still seeing my screen, correct?
Yeah.
Okay. So this is a game that I took from studio.co.org. Again, the link will be available to you if you wanted to take a look further. So basically, it says this is for small kids, but it emphasizes the concept that we just spoke about. So garbage dumped in the water affects marine life. And in this activity, you will program or train the AI to identify fish or trash. Let's clean up the ocean. Click anywhere on the screen to continue. So as a person, so I'm purposely confusing the system, but I actually shouldn't do that. But if you, the point I'm trying to make here is like, if you train it well, you get good results. If you don't train it, you're gonna get incorrect results. So let's try and train it the good way, right? Let's be a good person for today. Fish, 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 fish. Let's just give it for like 10 more and then like, let's continue to see how it works. I'm going to stop it right here and see, continues to see how we are at 46, right? Let's keep it at 50. 47, 48, 49, and let's see how this performs. So this is the process where you're doing the supervised learning, where you're feeding a bunch of data. You also labeled it to say it's fish or not fish. And the AI is trying to learn from whatever you taught it to be. And then it's trying to as you can see, depending on how you trained it, it was able to correctly let pass the fish and filter out the junks from the ocean. It need not be 100% accurate. Sometimes it could drop the fish, or sometimes it could let the trash also. It all depends on how you train the model and how much accurate the model is. This is a small game that I wanted to tell you in a visual way to say this is how machine learning works. You have a trained data, and then you train the model. Until and unless you're satisfied with the accuracy of the model, and then you test it on a test data to see if it's performing well, similar to the assessment that we all have. And then if you're satisfied with the assessments, you kind of implement it in real time in real applications and keep tweaking it and maintaining it. If you're not satisfied, you go back to your training phase, tweak in the model, and start all over again. This is one of the examples of training and classification. With that, I'm kind of done with the topics that I wanted to cover today, and I'll be happy to take over any questions if you have, or anything that you want to share or talk about, or how you felt about the class, or did you guys wanted to know about something else for us to come back with? Let us know.
Are you guys gonna be here next class?
What is it?
Are you guys gonna be here next class?
We are always here. Like if you see me, I'm always with Karthik in the background, but Karthik is the one who leads the class. But this class won't be happening next time. You will go back to the class that Karthik was teaching you guys, because that's the right path to kind of understand the data science. And this was like kind of a filler class to introduce you the concept. So, but we'll be there for the next class if you have any questions specifically for us, if that answers your question. You can always see me like AEC Nitya on the screen, and that's me just sitting in the background. Did you guys like the class? Did you guys get a feeling of what the AI, ML, and real world applications is?
Yeah.
Okay, glad to know. Now it's all up to you. Take it back. Enjoy the weekend. Do some research, a little more on these things. It'll be fun now that you know what these AI systems are. Whatever you see, whatever you hear, your mind will automatically start thinking whether this is using AI, this is using ML, whether it's using supervised learning. Try to think along those lines to keep your mind more warmed up and like more alert on that end, right? With that, thanks Shagan again for taking us through, and thank you guys for being here with us like for almost 2.5 hours. And the slides will be posted on your Agora Engineering Circle, and we'll be happy to take any questions offline too. Take care and talk to you.
I have a quick question.
Sure.
So, the homework from last class, we were allowed to have an extension if we needed it. So, can I get an extension for like a few more days? I just have 2 questions left to finish.
Yeah,
same here.
Go ahead and submit as early as possible. The coordinators, all of us will then take a call and evaluate. Doesn't matter, just go ahead and finish.
Okay, thank you.
Anything else? Okay, well then, thank you so much. Happy weekend, and talk to you all next class.
Thank you, Nika. It was a nice
Bye. Thank you. Have a great weekend.
Thank you.
Bye. Thank you.
Bye.
Thank you.
Bye.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!